Assalamualaikum warahmatullahi wabarakatuh. Today, I would like to share about the control and instrumentation engineer study guide. Today is 12 February 2021. As the instrument control engineers have to have knowledge about many of information, many of technology, especially related to the instrumentation and control. First of all, instrumentation control engineer have to know about what actually control and safety system. And the other one is about analyzer. Another one about detectors, flow measuring devices, level measuring devices, pressure measuring devices, switch, temperature measuring devices, density and viscosity measuring devices, instrumentation bulk material. Well, starting from the control and safety system, instrumentation control engineer have to understand about the integrated control and safety system called ICSS. Control system. There are several control systems inside. First, about process control system, PCS. In other words, integrated control system or DCS. Programmable logic controller or PLC. SCADA system, supervisory control and data acquisition systems. Management systems, MIS, plant information management systems. LIMS, laboratory information management system. MES, manufacturing execution system. Another field which instrument and control engineer has to understand is about safety instrumented system, SIS. Inside that is fire and gas system, safety shutdown system. We just consider emergency shutdown system, ESD system, and also emergency depressurized system. And then another one is about for critical equipment like burner management system, BMS, subsea monitoring control system, compressor control systems, and then another monitoring package like valve remote control system, VRCS, tank gauging system, and then structural monitoring system, vibration monitoring for rotating equipment. This is instrumentation and control system engineer have to understand about this technology. The next about analyzers. Analyzers house and shelter. Analyzer, there are two types, with liquid application and gas application. Belong to liquid analyzers, multi-wave photometers analyzers, pH and conductivity analyzers, total organic carbon (VOC) analyzers, oil in water analyzer, water quality analyzer. Belong to gas analyzer such as multi-wave photometer analyzers, oxygen analyzer, process gas chromatograph, flue gas analyzer, moisture analyzer, mass spectrometer analyzer, tunable diode analyzer, gas analyzer, CEMS continuous emission monitoring systems, air quality analyzer. This is talking about the analyzers. Talking about detectors, instrument and control system engineer also have to understand what actually detectors, like gas detectors, combustion flame detectors, fire flame detectors, heat and smoke detectors. Not only that one, leak detection system for vessel, for pipeline, corrosion meters, fairly early smoke detection apparatus. Now talking about the flow measuring devices. Instrument and control system engineer also have to know the knowledge and technology about flow measuring devices, such as ultrasonic flow meters, multi-phase flow meters, mass flow meters, vortex flow meters, magnetic flow meters, variable area flow meters, turbine flow meters, target flow meters, positive displacement flow meters, mass flow controller, primary element of flow measuring, cone meters, industrial smart meters. Next, talking about the density and viscosity measuring devices. Such as inertial density measuring devices, oscillation, piston, resonance vibration, and another density measuring devices. Next, about level measuring devices. Instrument and control system engineer have to understand about level measuring devices such as level gauge, ultrasonic transmitters, radar transmitters, nuclear transmitters, displacer transmitters, radio frequency type transmitters, capacitance type transmitters, magnetoresistors, level profile interface, microwave absorption. Next, about temperature measuring devices, and some of the knowledge under temperature measuring devices to be understood by instrument and control system engineers, such as temperature gauge, bimetal thermometers, thermoresistance, thermocouple, infrared for temperature, other temperature measuring devices. Next, about the pressure measuring devices, instrument and control system engineer also have to understand about pressure measuring devices, such as pressure differential, pressure transmitters, pressure differential, pressure gauge, pressure regulator. Next, about switches. Some switches have to be understood by instrument and control system engineers, such as pressure temperature switches, limit switches, proximity switches, flow switches, float operated level switches. Next, about instrumentation block material. There are two types, which is instrumentation cables and machinery instrumentation. Instrumentation and control system engineer have to understand about instrumentation cables, armor and unarmored, heating cables for instrumentation, thermocouple cables, armor or unarmored, thermocouple compensate and extension cable, fiber optic instrumentation cable, miscellaneous instruments such as peak signal devices and peak detectors, mooring buoy, meter load monitoring system, non-sheeters, Johnson's box, electronic component for system, and so on. This is the area of knowledge that instrument and control system have to learn and become truly instrument and control system engineers. What are to be studied in instrumentation and control? Instrumentation, industrial instrumentation and control engineering theory and basic concept. This is a very important for instrument and control system engineers. Instrumentation control engineering formula used in industrial control system and field instruments like 4 to 20 milliamp and 2 to 15 psi conversion. Control and instrumentation engineering standard, electrical standard, electronic standard used in industry. Instrument technology such as hard, foundation field bus, Profibus, wireless hard, ISE 100 wireless, OPC, Modbus RTU, Modbus TCP, OT IT integration, etc. What other to be studied in instrumentation and control? Instrumentation design, learn about PNID, piping and instrumentation diagram, EFD, process flow diagram, loop drawing, product specification, design basis, design philosophy, system architectures and block diagram, power and heat dissipation sizing calculation, panel design, instrument sizing calculation, instrument datasheet, instrument hookup drawing, instrument selection, instrument application, instrument cable schedule, instrument material take-off, instrument index, etc. Instrument installation, operation, maintenance, and calibration. That also have to be understood, to be learned by instrument and control system engineers. That's what I would like to share with all of you today. We hope that this material will be advantage by all of you. And if you think that this information is beneficial for you, please kindly subscribe, like, and share. Thank you for watching.